Hi, this video is on solving rational equations. This is an introduction to it. So when we have a rational equation, it's an equation that's going to have rational expressions that are equal to each other. Typically they have at least one fraction in which the variable is going to be in the denominator. So our procedure is usually as follows. We're going to determine the values that make denominator 0. Those are going to be our excluded values. Very important. If the equation has a proportion, which they sometimes are proportions, you simply cross multiply and skip directly to step 5. Otherwise, we go to step 3. So in step 3, if it's not a proportion, we're going to find the least common denominator. We're going to multiply both sides by the least common denominator. And whichever way you had to do it, you are going to solve the resulting equation. Very, very important. The last step, check the solutions that you got against the excluded values, because you may end up getting a solution that's going to happen to be one of the excluded values and you cannot use that. Those solutions will be called extraneous solutions. They cannot be considered part of your solution set. Okay, very, very important. Also, we have an assumption here that you know how to find the least common multiple for rational expressions. If you don't, you're going to have to watch another video on that. This video assumes that you already have that basic knowledge. All right. So let's start with this. These are problems that look like proportions, and the way we do them is we cross multiply. It's the easiest way to do it. But before we're going to do it, let's take a look at denominators and let's see what's going to make any of the denominators equal 0. So from the first one, we know x cannot equal 0. From the second equation, you can easily see that x cannot equal 3. So those are our excluded values. After that, we cross multiply, and let's see what we're going to end up with. We multiply 5 by 2x minus 6, and here we multiply x by 8. So that's going to give us 10x minus 30 equals 8x. This equation is going to give us 10x equals 30 and x equals 15. Okay, 15 obviously is not on the list of our excluded values, which means this is our answer, and we are going to list that. Let's take a look at the next problem. So in the next problem, we want to look at the denominator, which is x plus 1, and we don't want it to be 0. So that means x cannot equal negative 1. So that's our excluded value. And now we can proceed with cross multiplication. Again, it looks like a proportion. So we multiply 2 times 2x plus 3 going this way. And it's going to equal 3 times x plus 1. That's another way. So that's going to give us 4x plus 6 equals 3x plus 3. And the answer here is going to be x equals negative 3. Just like in the previous problem, it's not one of our excluded values. So that is our solution. And we are going to write that. Okay. So when it's a proportion, it's pretty easy. But again, please make sure whichever method you use, you must check for extraneous solutions. All right, there's one more. Let's go ahead and take a look at this. So we have x in the denominator. So we want to make sure that it does not equal 0, which means x cannot equal 0, right? Because that's the only expression we have in denominator. Now we can go ahead and cross multiply. So when you cross multiply this, you are going to get x times x minus 3 equals 5 times 8, which is going to give you 40. Right? So we distribute this, x squared minus 3x equals 40. It's going to give us x squared minus 3x minus 40 equals 0. This is a quadratic equation. This can be solved by factoring. It's going to be x minus 8 times x plus 5 equals 0. It's going to give us two solutions, x equals 8 and x equals negative 5. Are any of them going to create problems for us? No. They are not going to create any problems because the only excluded value here is 0, and that it means that these two values are going to be our solutions. Okay. Let's go ahead and take a look at the next problem. So this next problem does not look like a fraction. However, you can turn it into a fraction by doing the following. It's actually going to be easier in this problem to do it like this. We're going to put it over 1, and then it looks like a fraction, right? We do want to make sure that y does not equal 0, because we have y in the denominator. And now we can go ahead and cross multiply. So multiply this way, it's going to give us negative 12. Multiply that way, we're going to get y times y minus 7. So it's negative 12 equals y squared minus 7y. And if I rewrite that by bringing 12 on the other side, it's going to give us y squared minus 7y plus 12 equals 0. And it's going to be factorable, y minus 3 times y minus 4 equals 0. It's going to give us y equals 3 or y equals 4, right? Any of them problematic? No, I don't think so. The only number we excluded was 0, and that's not what we have here. So these are going to be our solutions, 3 and 4. Okay. Let's go ahead and move on. So now we're getting into problems where you have something that does not look like a fraction, and that method that we just used is not going to work. Are we still looking for excluded values? Absolutely. So here we'll look at the denominator. It's the same denominator in both fractions. So we want to make sure m does not equal negative 1. That's going to be our excluded value. And now we can go ahead and proceed with that. So our least common multiple here that we're looking for, since there's only one expression that we have, the same exact expression we have in the denominator, is going to be m plus 1. And what we do is we multiply both sides of that by m plus 1. So this is what it's going to look like. M plus 1 times 5m over m plus 1 equals, multiply the other side by m plus 1. Okay. Here we're going to have to distribute where we have parentheses here. All right, like that. On the other side, m plus 1 is going to cancel. The whole idea of multiplying by the least common multiple is to get rid of the denominators. So on this side, we're simply going to have 5m. What do we have on this side? We're going to multiply m plus 1 times 4. So it's 4 times m plus 1. And then we'll multiply m plus 1 times this expression. And here, let me write this out. So here we are also going to see that these two things will cancel, and we're no longer going to have a fraction. So we have 5m equals 4m plus 4 minus 5. And when you solve this equation, m equals negative 1. And here is that situation that I have talked about previously in the beginning. We have an answer, a solution that we got is the one that is an excluded value. This is the only number we have. You cannot use that. The answer here is going to be, this one is extraneous. Cannot use it. So the answer here is no solution. Okay, or you can also write that like this. Okay. This is precisely why you need to check this, because you cannot use that number that we got. Let's take a look at the next problem. So what we want is, in here there is only one fraction where the variables on the bottom have x minus 9, so you want to make sure x does not equal 9, right? That will be our excluded value. What is our least common multiple? I hope you can see it easily. Since there is only one fraction, that would be the denominator of that fraction will be our least common multiple, and we're going to multiply everything by it. So we're going to do it exactly the same way as we did the other problem. So we're going to do x minus 9 times x plus 10 over x minus 9, x minus 9, I was right the first time, equals x minus 9 times 2. So we are going to distribute here. It's going to be x minus 9 times x plus x minus 9 times 10 over x minus 9 equals, here we can distribute, it's 2x minus 18. So right there in the middle you see that these two things will cancel, right? And what that's going to do for us is that's going to clear all our fractions, and we can continue now with this. So distribute this. This is x squared minus 9x. This is just going to leave us with 10. And on the other side we have 2x minus 18. Which once you rewrite that in simplified form, this quadratic equation is going to be x squared minus 11x plus 28 equals 0. This equation can be solved by factoring. I'm going to continue here. So it's going to be x minus 4 times x minus 7 equals 0. That gives us 4, and that gives us 7. These values are not going to be any of our excluded values, because the only excluded value is 9. So we're good with that. And we are going to write our solution here with those both numbers, 4 and 7. Okay? Moving on. Okay, next problem. Now we're getting into situations where the denominators are not going to be the same. But the first thing we're going to do is the same thing we did before. We are going to figure out our excluded values. So in this fraction is you have x in denominator, so you want to make sure x does not equal 0. In this fraction we have x plus 2 in the denominator, so x cannot equal negative 2. So these two are going to be our excluded values, right? And what we're going to do is we're going to remember that at the end. What is our least common multiple? Well, typically what you need to do is you need to factor everything and find common factors for your denominators, but these are very simple. None of them is a factor of the other, so the only way you can make a common denominator here is by multiplying both sides by x times x plus 2. This is our least common multiple. And that's exactly what we're going to do. So it's going to look a little bit scary at first when you do these types of problems, because you're going to have to multiply each one of the three terms here by that expression. It gets really long at first, but after you simplify it, it gets really nice. So it's going to be x times x plus 2 times 15 over x plus x times x plus 2 times 9x minus 7 over x plus 2 equals x times x plus 2 times 9. That's what I meant when I said it's going to get a little ugly at first. Here's what we're going to do next. We are going to cross out things that will cancel. So x on the bottom, x here will cancel. X plus 2 and x plus 2 here will cancel. And that's going to leave you with something that's going to look a whole lot nicer. So what do we have now? We have 15 times x plus 2. Here we're just going to have x times 9x minus 7. Here we're going to have 9x times x plus 2. We're going to distribute all that. Now we're going to have to distribute. So 15x plus 30 plus 9x squared minus 7x equals 9x squared plus 18x. It looks like a quadratic equation, but you see that 9x squared on both sides is going to end up canceling, and that's not a quadratic equation. It's just going to be a linear equation. We combine all the terms together, and what we are going to get after that is going to be 10x here, and the other side is going to have 30, which means x equals 3. Is that an excluded value? No, because our excluded values were 0 and negative 2. It's not any of them. and that is going to be our solution here, x equals 3. Alright, moving on. Got a few more problems left to do. So here we're gonna have to figure out our excluded values first. So what we have here, b cannot equal -1, and here b cannot equal 1. So b does not equal -1, and b does not equal 1. These are going to be our excluded values, right? What about the least common multiple? Very similar to the previous problem. None of them goes into the other, b plus 1 and b minus 1, so you're gonna have to multiply them by each other to get the least common multiple, and that's the quantity that we're going to multiply everything by. And just like the previous problem, it's gonna get a little busy at first because 1, 2, 3 things, each one of them gets multiplied by this. So we're gonna have b plus 1 times b minus 1 times 3b minus 2 over b plus 1 equals 4 times b plus 1 times b minus 1 minus b plus 1 times b minus 1 times b plus 2 over b minus 1. Yes, these problems always get longer at first when you multiply, but after you cancel things it gets a lot nicer. So moving on, what do we have here? We have b plus 1 and b plus 1 that are going to cancel, and here is going to be b minus 1 and b minus 1, right? After that, all our fractions cleared, and we can just go ahead and multiply. So here we're going to have b minus 1 times 3b minus 2. Here we're going to have, I can multiply these two together. I hope you recognize this is a difference of two squares. This is going to be b squared minus 1 minus, and here we have b plus 1 times b plus 2. So we're going to have to distribute this. So over here we're getting 3b squared minus 3b minus 2b plus 2. Here we're going to get 4b squared minus 4, and here we're going to do minus. Please be very careful when you do it. This trinomial, just this part here, is going to be b squared plus 3b plus 2. But remember, we're going to need to distribute this negative sign. We can simplify it. This is 3b squared minus 5b plus 2 equals 4b squared minus 4 minus b squared minus 3b minus 2. Okay, so let's see what's going to happen here. That looks like a quadratic equation. Is it? I don't know. Now on this side you have 3b squared, on this side you have 4b squared minus b squared, which is also 3b squared. This is going to cancel. So it's actually not a quadratic equation because all the quadratic terms cancel. And what are we getting here? Let's see. So if I bring b's on this side, that's going to give me negative 2b here. And on the other side, I'm going to have 4 minus 2 minus 2, negative 8. So b equals 4. That's not any of the excluded values. So 4 is a good answer. We are going to keep it. And that's what we get. Right. Next problem. So here we have to do some factoring before we can even get our excluded values. So let me rewrite that. The first fraction stays intact. The second fraction, p squared minus 9, factors as p plus 3 times p minus 3. That's actually a difference of two squares. And the other side obviously is going to be 1/5. There is no factoring there. So first of all, we recognize that p cannot equal 3 and p cannot equal negative 3. right? Because one of those values will make at least one of the denominators equal 0. But also, when we try to figure out the least common multiple, this fraction has p plus 3 in the denominator. This one has p plus 3 times p minus 3. So this goes into this whole fraction. I mean, this whole denominator. So our least common multiple is p plus 3 times p minus 3, and also we have 5 here, so times 5. So this is going to be our least common multiple, and we are going to multiply everything by it. This one's going to get really long first, because we're going, well, let me move 5 in front. So 5 times p plus 3 times p minus 3 times 2 over p plus 3 plus 5 times p plus 3 times p minus 3 times 1 over p plus 3 times p minus 3 equals 5 times p plus 3 times p minus 3 times 1/5. Let's get all that stuff, and now we can cancel things. So here we can cross out p plus 3. Here you can cross out this whole entire thing, and here we can cross out the 5s, right? So let's see, it should get better after this. So we got 5 times 2, that's 10, times p minus 3. Here we're going to have 5, that's all that's going to be left out of that, equals, and here we're going to have p plus 3 times p minus 3, which I know is difference of squares, p squared minus 9. I can start multiplying things. So what do we have here? That's 10p minus 30 plus 5 equals p squared minus 9. We definitely have a quadratic equation. We need to move all the terms on one side and set it equal to 0. So it's going to be p squared minus 10p plus 16 equals 0. You can check this by moving all the terms around to one side, and that's what you're going to get. Factorable, p minus 8 times p minus 2 equals 0. Gives us p equals 8 and p equals 2. Both values are not among our excluded values. We can use them, because the only two numbers we cannot use are 3 and negative 3. So they both are going to be our solutions. Alright, and I have one last example. This problem. So first of all, just like the previous one, you have some factoring to do. Because at first you see 3 completely different denominators. So let's go ahead and rewrite that. So the first one, you cannot factor. This here, this trinomial here, actually factors as x plus 2 times x plus 3, which is precisely the combination of these two denominators. And that's nice. Equals 5 over x plus 3. So what x cannot be? Negative 2 and negative 3, right? X cannot equal negative 2 and x cannot equal negative 3. What is our least common denominator here? Well, the least common denominator, or least common multiple, is going to be this, x plus 2 times x plus 3, because both this one goes into it and this one goes into it. I should actually call them least common denominator, but the term least common multiple is appropriate too. I don't know why I started writing least common multiple, but that's okay. So we're going to multiply everything by that. And it's going to get pretty long at first. Do not be intimidated by that, because things should cancel if everything is done correctly. So we got that, and finally alright, so let's cancel what we can. Here we can cancel x plus 3. Here you can cancel this entire thing. And here you can cancel x plus 2. So it's going to look a lot better after this. Here we have x times x plus 3. Here we have 2. And here we have 5. Oops, I'm sorry, equals 5 times x plus 2. Let's go ahead and multiply everything. X squared plus 3x plus 2 equals 5x plus 10. So what we got here is definitely a quadratic equation. We need to move all the terms on one side. It's going to give us x squared minus 2x minus 8 equals 0. This one can be factored. It's x minus 4 times x plus 2 equals 0. And we have 4. And we get negative 2. And I hope you realize that negative 2 is an excluded value. It's an extraneous solution. Okay. And since it's an extraneous solution, we cannot use that. So the only solution we can use here is 4. Okay. And this is how it's done.